Hello friends, welcome back to my channel, and today we are back with another exciting tutorial. So this will be a continuation of our Kubernetes tutorial for beginners, and in today's video we are going to see how we can set up a zero downtime deployment Kubernetes. This is a very important lecture where you need to learn about this because this will be a base for how you can deploy your application in your production environment, so you don't get a downtime of your application when you want to upgrade and all those things. You will see how we can do this with Kubernetes downtime deployment. There are different kind of strategies, but here we are going to see about zero downtime deployment. So before I get into the actual details how we are going to do from one version of other version of application to be deployed, I will just give you a quick highlight on what we are going to do, and then we will get started. So let's get started about the topic. What we are going to discuss is about Kubernetes rolling update deployment, which is a strategy which we are going to do. So in Kubernetes there is a concept called Kubernetes rolling update strategy. What it does, it actually replace your old ports with the new ones gradually, and when continuing to serve the clients without incurring a downtime. So we will explain and how this is happening with a scenario like in production environment where we will run an nginx application as a service, and we will be accessing that web-based nginx in our web browser. So, and we want to upgrade it from one version to another version. So we will see, like, without any downtime, the application will be upgraded from one version to another version, but our service will be still running and the users will be able to access it. So, but when we talk about this Kubernetes rolling update strategy, there are two things, like one is a rolling update, another one is a recreate. So that's the Kubernetes strategy. So a rolling update, as we said, what it happens is, like, it's create new pods gradually, and the old pods are terminated gradually, so that it does not impact any service or your application. Whereas there is a strategy called recreate, where all pods are terminated before creating a new pods. And there is also other concept like blue-green deployments and all those things, which we will see in the upcoming tutorials. But here we are going to use a Kubernetes strategy. Okay, so before I get into that, I will also like to tell you, like, what is Kubernetes deployment and service. If you have not seen my previous tutorial, I would request you to go and have a look on my previous tutorial. So basically, we have a service on the front end, like where users are accessing our application, right? So we have a service exposed, and below the service we will have replica set or deployment. So deployment is the best use case, right? So where we have a deployment of our application, and on top of it we have our service. So usually when you create a deployment, you also will have a replica set, so you can define how much replica of your pod has to be run, so the replica set will be automatically created along with the deployment. So in the replica set we will be defining, like, how much pods we need, right? So in the deployment we'll be defining, like, we need 4 pods, or how many pods. So there will be different number of pods which will be running on our deployment. So based on the pod, like, the service will be able to access any one of the pods based on that. So now what we are going to do is we are going to see how we can upgrade the pods. The pod will be running with some container of your application, right? So we'll see, like, how we can upgrade the application without impacting your service, so where these pods will be recreated with the new versions. So let's see the Kubernetes zero down deployment with an example. So we are going to use an nginx version 1.21. So let's consider this is our base or initial stage before running our rolling update deployment. So we have a service on the top, right, on the front end, where I'm accessing the nginx application, where in the web browser I'll be able to see the nginx update or the web page. So but that will be serviced from one of these pod, right, nginx 1.21 version. Now what I want to do is I have a new version released from Nginx, which is 1.21.3 or maybe some other versions. So I want to update it. So what will happen is, as part of our Kubernetes zero downtime deployment or our rolling update strategy, what it happens is that when you run this new YAML file, which you have this strategy defined, so there are different parameters which we'll define, like we have a maximum search, maximum unavailable. So there are different things which we will define, which I will tell you in the upcoming slides, and I will show you the exact configuration, how we do it in our YAML file. So that I will show you like how you can define your deployment and also the service, where we'll be defining about these parameters, and also like a few other parameters to check the readiness and all those for the service. Okay, so in our case, what we are going to do is we are going to upgrade the Nginx from 1.21.2 to 1.21.3, right? So what will happen is, when you as part of our strategy, we have some configuration sets, like how much pod can be deleted, terminated, and how much pod can be recreated at the same time, or based on the configurations. So now what do you see is, as part of this example, like 2 pods running on Nginx 1.21 will be terminated, and the service will be, or the application will be accessible from the rest of 2 pods. At the same time, you have other 2 pods which is created on the new versions 1.21.3, but it's not started giving as a service. So now in the next stage, there will be a stage where both the pods are active, where the service can be accessible from any of these pods. So it can be reached from 1.21 or 1.21.3. so there is a stage where you have both versions of applications, but the service can be accessible from anyone. So for the end user, there is no difference, but even though there are different versions of pod running. So but as far as it goes on, this process, this update process, what will happen is, when the readiness probe, which will have said, it has shown like the application accessible from 1.21.3. so what it will do is, it will switch the whole connection to that, and it will try to terminate the other pods as well from the older versions. Now you can see the 1.21 will be removed from the service, whereas you have 1.21.3 new pods are getting created, which is still not accessible to the service. So it's still in the readiness check. So once the final stage, what will happen is, all the pods from 1.21.3 is active and all the pods are accessible. So then the service will be splitted on all the pods. So in this scenario, if you see, like from the first stage to this stage, for the service or the user accessing our application will not have any impact, because at always some point one of pods is available to give the service. So that's the Kubernetes deployment strategy, where you'll have a zero downtime, and these kind of strategies you should use in a production environment, so you should not face any downtime for the end users. Okay, so let's in the what we have shown in the pictorial way, let me explain you what it actually, the step-by-step process what we have done as part of the zero downtime upgrade. So the initial step what we have done is, like, initially all the pods are running on Nginx 1.12, right? And the front end service routes the traffic to these pods, because all the pods are running on 1.12. So during this rolling update, Kubernetes takes down some of the Nginx 1.12 pods, right? And creates a new version of Nginx, which is 1.12.3 pods, based on the maximum unavailable and maximum surge. So these are 2 parameters which we will set in our YAML file, which I will show you what is these parameters all about. So based on that, this how much pod has to be taken down and how much pod has to be created will be based on those configurations. So now as I shown the pictures, now we have 2 Nginx 1.12 pods are taken down and 2 Nginx 1.12.3 pods are created, right? And the Kubernetes will not route the traffic to the new pods until it's the readiness probe is confirmed or successful to the from those pods. So that's why the readiness probe is important, and when this new Nginx 12.3 pods is ready by the readiness probe, the Kubernetes start routing the traffic to it. This means the update process, users see both the service, old service and new service. So the users will be able to access the Nginx, but it can be reaching to any of these old service or new service. Okay, so this rolling update will continue until the all 1.12 pods are taken down, and creating new 1.12.3 pods, and the routing all the traffic to the newly created pods. So finally, all the pods are running on Nginx 12.3. So for the services are now all routed to these pods, and the users don't have any impact, or they don't have any downtime. Okay, so now let's talk about this readiness probe and the strategy. So if you see, this is a small part of our YAML file where we define this readiness probe, where we'll be talking about HTTP, and we are checking the path, and we have some configuration like initial delay, period seconds, and also we have a strategy where we define this rolling update and the maximum surge and maximum unavailable. So to give you detail about a maximum unavailable, so the maximum unavailable, this parameter, what it talks is like this: the number of pods that can be unavailable during the update process. So this can be a number like 2 or 1, or it can be a percentage. Okay, so that will be a percentage of the replicas. If you have defined 4 replicas, then it 50% means 2 of 2 replica can be taken down. So that's the maximum unavailable parameter. So it depends upon the replica you define and this value. So if you have put 2 replica, and if you put 50, means that it can take down one of the pods. Okay, so the maximum search, what that parameter is about, is the maximum number of pods that can be created over the desired number of pods. Okay, so again, this can be an absolute number or the percentage of replica. So this again, it's based on how much pods which we can create in this overall rolling update process. So if you have 4 replicas defined, so it means 50%, means 2 pods can be created. So in this scenario, like what we shown, like maximum unavailable 50 and maximum search 50, means it will be like if you have 4 replica, 2 can be taken down and 2 can be created. So as we shown in the picture, what we shown there, how Nginx upgrade happens, right? So now we also have this readiness probe defined, right? So the readiness probe for your service is to help the Kubernetes determine the state of the pods. So this is important because before this readiness probe is, and if you don't use it, if the Kubernetes try to start the service or route the traffic to those pods, which is not actually up, so this readiness probe will help Kubernetes to route the traffic to the pods with a healthy live probe. So this will help us to tell Kubernetes, wait, don't send those traffic to those pods unless we confirm that the pods are active and the applications are up. Okay, so that's the importance of that. So now we have some parameters we are using in the readiness probe as well, right? So there is something called initial delay second. So what does it means? Like, is the number of the seconds after the container has started before readiness probes are initiated. So it means like the number of seconds after the container has started. So it will wait for the container to start, and then this much of seconds to check the readiness probe. Okay, and the period second is like how often in seconds. So that's also defined in seconds to perform the probe. So how frequently you need to check the probes. It can be default to 10 seconds or minimum value is 1. Okay, and the timeout second, like number of seconds after which the probes timeout. So default is 1 second, minimum value is 1 second. So that means the probe can check it and it can time out after this period. Okay, so that's what that value is about. Then there is something called success threshold. That's the minimum consecutive success of the probe to be considered successful. So after having failed, default to 1 and minimum. So success threshold means like it will tell you like it can consider it as a success if it's run successfully for one time. So if you have put it as 1, if you have put it twice, then it has to run it twice and it has to confirm that it has success for twice. Then that will be only it's considered as success. So these are some parameters, so you don't have to use all in all configuration. Now you see in our case we have used 3. So depending upon the needs, you can define your YAML file on the readiness probe and strategy. Okay, so we'll see about how we have written the whole YAML file for deployment and service, and how you can use that in creating your pods and the service and deployment and all those things. Okay, so before I get into the actual demo on our system on the Kubernetes cluster, I would request you, like, if you have not subscribed to my channel or if you are new to my channel, click on the subscribe button and also like my video, share and comment. Now we are going to start with the the rolling update YAML file, because this is the important part where you need to know how to write this YAML. And I would request you to check my previous tutorial on the deployment and the service and all those things, where we have created this YAML file separately, and we only just adding some part here, like the readiness probe and strategy. Otherwise all those things are similar. Okay, so I'm going to explain this what we are doing here, and I will also link the GitHub link on this video description, where you can go and get this YAML file as well. So check out my video description for the GitHub link. So let's talk about this. So we have two parts. Okay, one part is the deployment and another part is for the service. Okay, so the first part is, you can have a two separate YAML file, or you can have it in the one file as well. So I'm keeping it in one file, so it's easy. Like I run it one file, it will create the deployment as well as service. Okay, so the API version for deployment is apps/v1, so you can get it using kubectl. Explain your deployment, then it will tell you what is your API version, kind, and all those things. Okay, so kind is deployment, which we are going to use. So you can also use like replica sets if you don't want a deployment. And we are using the metadata, where we are giving a name for our deployment, which is deployment rolling update, and it's we are defining as a namespace, which should be default. So you don't have to specify it, if it's a default, or if you want to keep it on a different namespace, you can define that as well. Okay, so it's not a mandatory field. And the specs, so here if you see, I'm specifying 4 replicas, so it should create 4 parts, right? And I'm using the selector, so I'm using the selector as match label app nginx. So it will look for any parts which is using nginx app nginx key value pair, and that will be added into this deployment. Okay, and the template, again, we are using the metadata, where I'm using the label app nginx and rolling update. So these are the 2 key value pair I'm setting, and this value I'm using it for the deployment, right? So where I'm using the match selector. And the specs of the container, as I mentioned, I'm using the image nginx 1.21. This is the initial version, and when I'm going to change or upgrade the system from 1.21, I'll be changing this image version to 21.3. so that will be the only change which I'll be doing. So once I run it, if your application you have using this kind of YAML file, what you need to do, you have different kind of images, right? So you have to put your image here, like image, and what is your path, whether it's in Docker Hub or it's in GitLab container or wherever it is, GitLab container registry or wherever it is, or JFrog, your private registry. So you put that link here of the version, and in the next version you can update it, and it will run based on that. Okay, so here I'm using from the Docker Hub, so nginx 1.21, and I'm using the image pull. It should pull the image always, and the name of the container is nginx container. Okay, and the port for this container is port 80, because it's a nginx. If it's a different application, based on that you have to change the port. And the readiness, as I mentioned, so we are checking the container or the pod is up. So in order to that, since it's a web-based application, I'm using HTTP GET, and the path is the home page with the port 80, right? And the initial delay seconds I'm using 5, and period second is 5, and the threshold as 1. So one success is considered as success. Okay, and this deployment strategy, so since we want to do this as a rolling update without with zero downtime for our application, I'm using the strategy as rolling update. Okay, so the rolling update, the maximum search I'm mentioning 50, and maximum unavailable as 50. So I want to take out a 50% of 4 replica, so, and also I want to create 50% of 4 replica when we are doing this rolling update. So that will be a part of our deployment. Then we go to the service. So once we have our deployment ready, the service has to be there to access it from outside, right? So the name of the service I have given, and the service should match with the labels app nginx. So if any ports running with this, it will be using for that service. Okay, so I've used different other labels which is not used anywhere, but still I'm using it. You can use any other labels as well which you can use it. And you see the selector, again I'm using app nginx as 0, selector for this service. Okay, and also I'm using this rolling update, and the type of the access for service we are using load balancers. There are different kind of expose, right? You can use cluster IP if you're using within your cluster only. So I'm using load balancer, so I can expose this application. So I'm using protocol TCP, and this is the port number for your application, and I'm using a node port as 3110, so 31110, so that it can constantly use this port number, so that whenever I create our service, it will be always mapping to this port number. So let's see how we can create our initial deployment and service. So let me go to my Kubernetes cluster. So I'm going to create a file called rolling update.yaml. Okay, and I'm going to paste this content which I just copied. So this will be the service part, and we have our deployment part as well. So I'm going to save this file, and before I start it, let me show you kubectl get ports. We don't have any ports. Kubectl get deployment. You don't have any deployment. And kubectl get SVC, we don't have any service. This is the default cluster IP service, but we don't have any service for application. Okay, so now let me clear out the screen, and let me apply kubectl apply -f and the YAML file or manifest file, which is rolling update.yaml. So once I run it, you can see it has created the deployment as well as the service. So if I go to kubectl get deployments, you can see the deployment is created, but it's still not ready. And if I go to kubectl get ports, you can see the ports, it's almost created. 3 is created, 1 is creating. So yep, now all the ports are created. I think one more has to be ready. So let me see. Yeah, so it's still getting ready. So let me see kubectl get deployments. Yeah, you can see all 4 are up, right? So now in order to access, we need to check the kubectl get SVC. We have the service also created now, so we can check the URL for the your service. So we have our service, which is the service rolling update, right? So let's use Minikube service and the name. So that will give you the details about the service. So you can see this is the URL to access it. Okay, so since I'm using Minikube, I'm using this. If I also shown you how to set up your own Kubernetes cluster using a master node and 2 worker nodes. So you can use that method as well to set up your cluster, and you can use this same YAML file. So it will be doing the same thing. Okay, there is no change in the configuration or manifest file. It can be used anywhere. So if I access this URL using our service IP address and the port number, you can see I'm inside the NGINX page, right? So, and I also, if I describe, okay, let me clear out the screen. If I go to kubectl get deployments, and if I describe kubectl describe the deployment, so what we need to do is, I just missed kubectl describe deployment and the deployment name. Okay, so now if you see, it will tell you the whole details about your deployment. So let me go up a little bit, so you can see it is using the image, right? So where it is, you can see this is the NGINX image, right? So it's using the NGINX container, which is 1.21.3, right? And you can see what's the rolling strategy and all those things. So you can see the whole details about this, right? So you can also check this with our pod. If you see kubectl get pods, and if I describe kubectl describe pod, and if I use one of the pod, you can see it's showing like pulling the image 1.21, and it has created the container using that image, right? So you can see these are the ports now running, right? V84 XX, V9 GV8. So these are some ports running. Now I want to update this app, right? So if you see it's still running because all the ports are running. So what I want to do is I have a new version now released. So I have 1.21.3. So I will just save this file. I will copy this and I will go back and I'll create another file called rolling update 21.3.yaml, or maybe I'll just use 3.yaml simplified. So rolling update 3.yaml, okay, and any name you can give it. I'm just going to paste this content. So only change I have done it is I have just changed the version to 1.21.3, right? So this is the image name. So I'm going to save this file and I'm going to apply now kubectl apply -f rolling update 3.yaml. Okay, so now you can see it has been configured and the service there is no change, because the service there is no change, only the deployment has changed. So you see kubectl get deployment. Now you can see 2 is ready, 2 is up, so I have to quickly check kubectl get ports. So you can see the ports are getting terminated and other ones are getting created, right? So we need to be very quick because it has already downloaded the image and everything. It has already deleted some of the ports and it's creating new. So actually it would have deleted 2 and then it would have created 2 new ports, and it will go on like that. Okay, so it's terminating the other ones. Let me also show you, like if I go to kubectl get deployment, and if I go, you can see all deployment is all up now. So if I go to kubectl describe deployment and the deployment name, now we can see it has quite some changes over here, right? So now we can see the image is 1.21.3, right? So it will tell you all those details. It would tell like scale up and scale down, right? So it would have deleted some of the ports and some of those ports has been recreated. So you can see those details over here. Okay, so that's the overall process. So let me also show you, like in the port. So kubectl get ports. Now you can see all ports are running, and if I describe one of the pod, you can see all the ports are having new name. Now you can see this pod is using 1.21.3, right? It's not 1.21. And if I go to access the page, it's still accessible because we have updated the image. It has even when at the time of doing the update, if you access the web page, it will be still accessible, because at the time also we should have any one of our service running, whether it's maybe from old or it can be new, or it can be combined of those in the one some stage where it can be both ports are running. So that's the overall process, like how we can do this upgrade without affecting your production environment. You can do a rolling update. So you can see what we have done is we are using the strategy for rolling update, where we'll have 50%, right? Or it can be anything which you want to use, and also we are using the readiness probe on that, right? So that's the overall thing. I will give you the link for this whole YAML file in the video description, where you can go to my GitHub location and you can download this. That's the overall process we wanted to do. So I hope you're enjoying this tutorial. So thank you for watching, and to watch more videos and to support me, I would request you to subscribe to my channel and also like my videos and share and comment.